All right, everyone. So for the final lecture of this module, I want to talk a little bit more about plotting data. Because we explored it in Excel, but Excel is not the main program that you're going to do your plotting in. Once you learn something like R or MATLAB or Python, you'll spend the majority of your time plotting in there because graphing is easier and more reproducible. It's not going to feel like that at first. At first, it's going to take you, 5 times as long to do a plot in R than it will in Excel. But as time goes on, it'll become less and less until finally it's much quicker for you to do it in R. And because you can save your code, you'll be able to use it again and again in the same theme or the same data set to where it becomes really, really fast to generate output. And you'll really never go back to Excel again. All right, so first we're going to go over some good plotting practices. There's 2 main types of plots that you're going to make. The first are exploratory plots. Their objective is to explore your data. The intended audience here is going to be yourself or other scientists that are familiar with your work. This is important because the objective here is to confirm and analyze. These things are not going to be pretty. You're trying to save work and not make all of your axes beautiful and all of your colors perfect. You're just trying to get your data displayed in a way that has it clear and accurately represented so that you can see what everything is all about, and you can easily show it to your colleagues and people that are familiar with your work and say, this is my latest result, and this is what it looks like. The second type of plot is an explanatory plot. That's to explain your data to other people that might not be as familiar with your work. This means that when they look at it, you're going to need to label all of the different things in the plot. You need to have your different color schemes to denote different conditions in your categorical data, all of your different categorical data labeled. You want to have all of your axes labeled. You want to have the scale look nice. You want to have everything look nice. This is kind of a mediocre explanatory plot. You want to have them look a little bit nicer than this, but I just pulled this one off the internet real quick. But this would be an explanatory plot because they did the work to label a lot of things. The intended audience there is a reader or layman, someone that's not familiar with your work, and your objective is to inform and persuade them. And it's important to remember when you are writing or making figures that the more time someone has to spend understanding what you've put down, the less time they have to think about your work, and usually they blame you for not being able to understand it. Most people are reluctant to say, well, no, I just don't understand because I'm not capable of it. They'll be like, this is poorly written and I don't understand what these things are. So the onus is usually on the writer to make it legible and on the figure maker to make it easily accessible by eye. And again, that's why I say this explanatory plot kind of sucks because I don't know what seg1 is. I don't know what CC is. I don't know what MI is. These colors, I mean, they're different, but I don't know what we're looking at here. There's no title. It's kind of a garbagey explanatory plot that I pulled off here. Maybe I'll go find a better one by the end of this. Okay, so data axes. On your x-axis, you're always going to want your dependent variable. You can see here that they have their different categoricals, seg1, CC, MI, whatever the hell those things are. They're all represented here. And on your y-axis, you're going to have your independent variable. They're plotting a range of some kind. That is clearly their independent variable. This applies to both scatter plots and to box plots. All types of plots, you want your x-axis to have your dependent, your y-axis to have your independent. There's 2 comparisons you're usually going to be making. One is continuous versus continuous, and the other one is continuous versus categorical. So for continuous versus continuous, we've already seen these before. You're going to end up using a scatter plot. This has, one continuous set on the x-axis and then one continuous set on the y-axis. An easy additional layer to any scatter plot is to color the different points by different categories. So, smoking population in one, non-smoking population in another, plotting like the cholesterol versus the weight, something like that. You can have different categorical data plotted on a continuous scale. It is possible to add continuous data to a scatter plot, but it generally doesn't come out all that nice. You could add like a rainbow, a color scale going from red to blue of, you know, how fast something is going, and the colors represent how fast it's going. But adding a third continuous variable generally doesn't come out looking all that clear. So as a rule of thumb, I would go with a continuous variable plotted versus a continuous variable with one categorical variable's worth of color metrics added to the scatter plot. For a categorical versus continuous, that's what you're looking at up here. These are usually box plots, dot plots, or violin plots. The box plots are falling out of favor. We'll talk about that in a second, in favor of these dot plots and violin plots. But that's your categorical versus your continuous. There's not a lot of easy conditional layers to add to this. Mainly, it's just more and more categories. You'll see that here they have 3 different conditions, and then in each of the conditions there's a gray and a red. Basically, you can add as many categories as you want on the bottom, but it starts to get messy after a certain point, so it's very difficult to add a lot more to one of these types of plots. And finally, for single continuous variables, we'll be talking about histograms, density plots, and distribution plots. I think distributions and densities we've kind of seen before with probability distributions, and we'll be focusing more on histograms today. Okay, so histograms. When are we going to use a histogram, and what is it? Well, first of all, we're going to use a histogram when we first want to get a feel for how our data is distributed. So when we first open up a new data set and we don't know whether it's skewed, like we talked about in a previous lecture, or we don't know if there's bimodal with multiple humps, we're not really sure what's going on with it, we want to plot it to see what it looks like. And it's important, you can only use a histogram when you need to display one data distribution. If you're trying to display multiple things, you're going to end up using a box plot or a violin plot or something else. So what is a histogram? I've made this movie to kind of illustrate to you what a histogram is. So say we have this data distribution up here. That's going to determine the probabilities of the samples, and these little red dots are going to be an accumulation of sampled points. Every time a point falls within a bin, which is a region on the histogram, it's going to increase the bar by 1. So right now there's 1 point being plotted, and each one of these histograms with a bin size of 1, bin size of 2, and a bin size of 5 has a little hump where that single thing is being registered. So we'll start to get this going here. So you can see the points starting to accumulate. They're going to form this data distribution eventually over time as we sample more and more. All right, so how do we determine the bin size? I'm showing you 3 different bin sizes of a histogram here. Generally, you'll guess and test. It'll be a lot of trial and error. If the bin size is too small, you won't really be able to see the shape of the probability distribution or the distribution that you're looking at, right? It'll end up being too flat and jagged, and there'll be space in between the bars, and generally you don't want to have any space in between the bars. But if you make your bin size too large, it becomes hard to see anything other than a mound. So once we get up to a bin size of 5 for this data set, now we're really just kind of looking at a mound. So a bin size of 2 here looks pretty good. There's no space between the bars, and I can get a feel for the contours of the distribution. And finally, if there's meaningful values for your distribution, like there's a spacing to it where they only fall every 5, right? Because the scale that you're measuring something on only has a precision of 5, right? You wouldn't want to make your bins 1 because that's below the level of precision in the experiment. You'll run into meaningful values every once in a while, which should limit your bin size, and pay attention to those. So how are we going to make them? Well, you can make them in Excel. There's an insert histogram function in Excel. But I'd say most likely you're going to do a better job using, I did this in MATLAB, but you're going to be using R, and ggplot2 does a very nice job with histograms, and we're going to see some of that later. All right, so what about box plots? I already showed you one of these box plots earlier. Let's break down what a box plot is. So this vertical thing, I've turned it on its side, and we're going to take a look what all of these different elements are in a box plot. So a box plot is a representation of the histogram we just saw on the last slide. So when it's laid on its side like this, this could be a normal distribution that comes up like this and down like this. And what these different bars mean, first there's the median. The median is the middle number in a set. So if it's, 1, 2, 2, 2, 2, 3, 4, 5, 2 is going to be the middle number in that set, so then 2 is going to end up being the median. Essentially, when you divide the data set in half, whatever number is closest to the middle is going to be the median. I think I talked about this in a previous lecture. The percentiles are just like the median, except instead of halfway, we're looking at 25% or 75% of the way through the data set. And then the region that lies in between the 25th percentile and the 75th percentile is called the interquartile region. It's where 50% of the data ends up falling. Then there's a formula for the minimum value and the maximum value in the data. These are just determined by quarter 1 minus 1.5 times this interquartile region, and quarter 3 plus 1.5 times the interquartile region. And then anything that lies beyond are considered outliers. Outliers are values that are not calculated, are not factored in when you're looking at a mean. They lie so far away that it's thought that they are statistically improbable enough that they should not be counted in any statistical calculations. Okay, so when do we use box plots? Box plots are pretty good representations when your data is normal and unskewed. They're the most common, or they have been the most common in the past, but they're really falling out of favor now because a lot of the time your data is not perfectly unskewed, and if it is in a weird shape, the box plot's not going to show you that. So it can be used to hide weird shapes from people, and we tend not to like that. We want to see the data for how it truly is, and there are better ways to display that these days. How do we make them? Well, they can't easily be done in Excel, but they can easily be done in R with ggplot2, as I'll show you. ggplot2 is a package in R, and we're going to show you how to install some packages. All right, so what about violin plots? Violin plots are showing you the same thing as the box plots, but remember I said that the distribution is being obscured in a box plot? On a violin plot, it's showing you that whole distribution. So it's basically if you took like a smoother to a histogram, plotted that histogram on its side, and then made a mirror of it, right? And sometimes, in this case, you can plot a box plot inside of a violin plot. So this black line here is the box plot. The purple is the violin plot. The box plot regions, the median, the interquartile, the two quartiles, the lower and upper quartile values are all the same as what we talked about in the last slide. But you can see that if you were just looking at the box plot here, you wouldn't be able to appreciate this like wobbly little violin-like shape here, right? But with the violin plot, now you can appreciate that there's a bimodal distribution to this particular set of data, and that could be significant to how you interpret what's going on. All right, so when do we use these? Well, they're better than box plots because they give us more information. We can see the actual distribution of the data, whether it's normal or not normal. They're currently less common than box plots, but they're growing in popularity, and you should expect to see a lot more of them. The hard part about them is that they require a programming language like R to make, but with ggplot2, it's going to be pretty easy to do. They can't be done in Excel, can be done with ggplot2, which we'll see in a second. All right, so what about dot plots? So there is one other reason why you wouldn't use a violin plot, and that's when you have too few points. So violin plots, even though they show you a data distribution, they're not giving you any count values like the histogram did, right? You don't know how many points are built up in any particular peak in a violin plot. But if you use a dot plot like this and stack it like a violin, Now you're getting the benefit of a violin plot because you can see the shape of the distribution, but you're also getting the benefit of a histogram because you can count how many particular things fall in a region, right? So now you're stacking your dots and piling them up, and you're able to get the benefit of a violin plot even when you don't have a lot of points. So dot plots are what you use when you have, say, less than 50 points. Violin plots over 50 points. Box plots pretty much never, unless your data is perfectly normal and you want to be old school. Okay, so like violin plots, they preserve the data distribution, and they also require programming languages like R to make. Can't be done in Excel, easily done in R with ggplot2. All right, so at this point, I'm going to hop over to R, and we're going to run a bit through this script that I've posted for you that will allow you to see some good plotting techniques that you can use. So the first thing you're going to want to do is to install two packages. One of them is ggplot2, which is going to give you all the functionality and plotting that we see in this particular demonstration. The other one is readxl. This one will allow you to read Excel tables easily in. I don't use it here, but it's a good one to have, so I put it in there for you, since anytime you want to take Excel data into R, you'll want this readxl package. So the first thing you want to do when you run these things is to highlight them and then run them. Control-Enter is how you run in R. Right now it's giving me an error message because I've already installed these things, so I'm not going to install them again. But the first time that you do this, you should install them. After you're done installing them, you can put little hashes in front of them, and then you won't install them anymore. The thing you will have to do every time you load R is get your libraries and load them, right? So library sort of activates these packages so that R knows that you're going to be using the functions that are in there. So the data that I'm going to be using today is input from this input data text, which is also in the PowerPoint folder that should be online. It's a random thing I pulled offline. It has a bunch of ages, heights, weights, and cholesterol levels, along with whether or not a person smokes, what their blood type is, and whether or not they're alive or dead. So if you want to explore the data structure in R, str does a good job. It'll show you the different factors, which are denoted by these little number signs, and then the first couple of things from each. It also shows you whether things are factors or whether they're continuous distributions denoted by int. So factors are categorical data. Int here are integer data that is continuous. All right, so with the old non-ggplot histogram, you can do histogram in R and you can mess around with it, but its functionality is just not as good. Here's a histogram of the ages of people in this study, but let's go on and see what we can do with ggplot. So first we're gonna shift over to a scatter plot. The way that this language works is you're going to say, okay, ggplot data equals my data 3, AES, which stands for aesthetics. You'll have your X and then your Y, and then you'll do plus whatever type of graph you want. In this case, we want geom point because geom point denotes a scatter plot. And when we do this, now we're plotting age versus cholesterol on the X and the Y axis. So this looks good, actually. We got some points. They're all scattered about, and they are on our axes. But now let's say I told you before we can easily add a categorical data to a scatter plot with two continuous. So let's add color these by whether or not they smoke. So here now I've said, all right, I have my age, and you could do like X equals age if you want, or Y equals cholesterol, and then color equals smoke. And now they're colored by their smoking, non-smoking pipe or cigarette. And these capital age, capital call, and capital smoke, those are just the titles or the names of the factors in this data frame which we've we've imported from the text file. All right, so our plot's looking a bit nicer. You can see what we did. We just added color equals smoke. We still have our geom point. But now let's say we want to add a smoothing fit. The nice thing about ggplot is that we can simply add on things on top. So we have our geom point, which is our scatter plot. And now we're going to add a geom smooth onto it. Geom smooth is a smoothing spline. It's a type of fit. And now you can see we have 3 different lines, one for non-smoking, pipe smoking, and cigarette smoking, added on top of our scatter plot. And you can see I also made the points translucent in the center by doing geom point alpha equals 0.4. Alpha is how transparent or translucent things are. All right, so the modularity of the ggplot thing should start to become apparent to you now. We just keep sort of adding stuff on, and our plot gets even better. So now I'm going to do the whole thing again, except we have our data equals my data 3, aesthetics, age, cholesterol, color equals smoke. But now I'm going to say geom point with alpha equals 0.8, shape equals 2. So now I'm going to why is this? I want to change the error bar color. Oh, I added a plus here. My bad. Sometimes you have errors. And we'll just do that, and it'll say no. I added this random plus thing here. We don't want that. Okay, and now we run it again. All right, so what I've done. Inside the geom smooth, which is where the spline fit is, I can change the size of the line. And so I changed it to size 2, and now you can see they're all thick. I also said aesthetic fill equals smoke, which means that those gray error bars on that line are now colored by the smoke, whether or not the person is non-smoking, pipe smoking, or cigarette smoking. And you can see that makes the lines easier to parse. I also changed the shape of the points. You can do shape equals 1 through up to 20, I think. There's lots of different points that you can make it: circles, squares, crosses, whatever. That was just to show you can change the shape. And you can also change size in this way. So inside each of these little modules, you can start to mess with how things look. So that's really great, but what if we wanted to change axes? Well, let's go back to our modularity now. All of this is totally unchanged. All we've done is add on labs, which is labels. We label our X in years, and our Y is cholesterol. And now you see age years and cholesterol milligrams per Gonna make this a little bigger. I think I made it weird. Okay, that's pretty good. All right. Milligrams per deciliter. Okay, so that's one way to do your labeling, but there's actually a more robust way to do it. So all of this is now the same, but now instead of adding labels, we're going to do scale X continuous and scale Y continuous. This allows us to add in our label, but also set where we want our X and Y axis limits to be, and the breaks, which is where we want the different ticks to be, and then expand just says how much space you want before and after your limits. Usually it gives a little bit of space. I usually set that to 0, so I can set exactly where I want my limits to be. So now we do that. And look, we now have changed our axes and made some more ticks, and there's some triangles everywhere. Yeah, so that's looking pretty good. All right, so now let's say we want to change the font size of the axis. So font size and things like that are have to do with theme. And so here we could say axis title, which is the title of the axes, element text, size equals 15. So what we're doing there is we're changing the size of the axis. And now we see we've made our axis titles a little bit bigger. And I want to encourage you afterwards to just run through this script, keep it for yourself, use it for yourself, use it as a jumping off point. I will say that everything that I just did here, I basically Googled the hell out of it. Like, I just thought, well, what do I want to do? I'm going to Google a bunch of things. As you get more and more well-versed with ggplot, you will know some of this stuff by heart. Like, I know how to do scale X and scale Y continuous. But when you want to change the axis title or the figure legend, you're just going to end up looking this stuff up on Google. So don't be afraid to really dig into the internet and look at a lot of the blog posts that have really good ggplot tutorials. All right, so that's as far as I'm going to go with scatter plots. But let's look a little bit at histograms. So here's the base histogram in ggplot. We can see it's already a lot nicer than that histogram we were looking at in the other place. But the first thing we want to do is modify our bin width and say, okay, these bins look a little too small. There's a lot of spaces here. Let's make our bin width 20 and put center 10. Center 10, you always just want to, when you do your bin width, have center equal half of what the bin width is. And now we can see we've made our bin width a little bit larger, and I think that is a little bit smoother and looks good. All right, but what if we want multiple species? So say we want, right now we have the aesthetic sent as cholesterol. We're plotting our cholesterol on the x-axis, and that's about it. I told you before that's mostly what you're going to be doing, but R is good enough that you can almost get away with plotting multiple histograms on a single plot. I wouldn't do it that often, but if you want to, for a publication, but if you're doing an exploratory plot, it could be warranted sometimes. So now that same histogram is broken into colors that are stacked on top of each other. The cigarette smokers, the pipe smokers, and the non-smokers. But I find this is kind of hard to parse because they're all just kind of stacked up on top of each other. So right now with them stacked, it's kind of hard to see. So instead, you could change their position to identity, and now each one of them is shown as its own histogram, but they're all translucent, so you can kind of get a feel for where they all are. Again, I'm not that big on plotting multiple histograms, but this lets you do it if you want to. And just like for scatter, you can change the axes and all that stuff. So I've added in scale X continuous to get some axes labels and set where I want my limits and breaks. Same thing with Y. I've used my theme to change my axis title and my legend title sizes. And I've also changed the name of my legend here and the different things. So right now they have smoke and non-smoke, and I don't like all that. So I said, all right, I'm going to make it smoker status, non-smoking, pipe, cigarette, all that type of stuff. But yeah, in general, stick to one variable for histogram. All right, so let's look at box plots. This is your categorical versus continuous go-to. This is your base box plot package. You have your data, then your aesthetic. In this case, we have smoking or non-smoking on the x-axis and the cholesterol on the y-axis. And then we add on our geom box plot. So now we're going to do the same thing, except we're going to color it by blood type. And you can see when we do this, now A, B, B, and O are different color boxes, and they're in each of the different categories. So that's that adding a categorical onto a categorical I was talking about before. You could do all the same axis tricks that I was showing you up with the other plots down here. I'm just not going to run through them for time's sake. And now let's look at violin plots. These are the same box plots that you just saw, except now they're in violin form. You could see that it has the same basic start. Data equals my data, X equals smoke, Y equals call. But instead we have geom violin, and I've just changed the fill here to be black. But I think it looks pretty nice to start. And all the modifications and modules that we were using and the other things for the axes we can again use for these violin plots. And just to show that, I went through and added some pizzazz to the axes. I angled some of the axes, I changed the colors, here and made them all smoking. There's more text here that you can look through if you want. I tried to change things one by one. In this case, I messed with the background some. So now I filled it in with gray, and I got rid of some of that gray background and put some black lines around our violin plots, and I'm thinking it starts to look marginally nicer as you do this. There's so many different ways you can change the faces and the colors when you go into this theme function here, and that's something you'll just have to explore for yourself over time. And finally, that same functionality can be done with box plots, it can be done with dot plots. The start is the same, data equals my data 3. Aesthetic is smoke. I have it set as factor smoke, but I think it could just be smoke. Y equals cholesterol, but I don't think I need the Y equals. And then I have the geom dot plot here. Yeah, geom dot plot. The bin axis, you have to specify which axis you want things binned upon. In this case, the Y, and then the center just means that I want it centered like a violin plot, except with dots. Just run that again. Yeah, so that's fine. Okay, so that's all of the R tutorial I'm going to go through for now. I'm going to give you this whole script if you want to look at it as a jumping off point for making your own plots. And I also am posting this really nice summary of ggplot and all of the different things you can do. Like as you can see, the geom.plot and geom violin we just went through, geom smooth. So all kinds of stuff to do here. And at first, this is going to be hard and annoying, and you're not going to want to do it. But over time, it will become second nature, and it will become a skill set that allows you to make beautiful plots really quickly and reproducibly for all of your research.